Sailors returned from the open ocean with stories that sounded impossible. They described walls of water rising out of nowhere, waves far taller than everything around them, steep enough to look like cliffs, strong enough to smash bridges, crush steel, and make large ships feel suddenly helpless. These were not ordinary storm waves. They were something else, something singular, something violent enough to feel almost unreal. And for a very long time, many scientists did not believe them. Not because the ocean was considered safe, but because the mathematics of wave prediction did not leave much room for monsters. Traditional statistical models suggested that truly gigantic, isolated waves should be extraordinarily rare. Rare enough that many reports were treated as exaggeration, fear, bad memory, or maritime myth. Yet the stories kept coming. Ships vanished. Hulls were damaged high above the waterline. Crews described a single enormous wave arriving from the wrong direction, with a deep trough before it and a vertical face that looked less like water and more like a moving wall. NOAA says rogue waves are greater than twice the size of surrounding waves, often look like walls of water, and are highly unpredictable. Then, in 1995, the ocean stopped arguing in stories and answered in numbers. On New Year's Day in the North Sea, a laser instrument on the Dropner platform recorded a wave about 25.6 meters high in a sea where the significant wave height was around 12 meters. It was more than twice the height of surrounding waves, a true rogue wave by the scientific definition, and it was recorded by instruments, not imagination. That event became one of the turning points in ocean science. ESA later described rogue waves as something once dismissed as nautical myth, but now accepted as real and dangerous, with satellite observations helping establish that they are widespread in the world's oceans. That is what makes this story so compelling. The giant waves were real. Sailors were not inventing them. The ocean had been producing these monsters all along, and for years, the scientific world was slower to accept them than the people forced to face them at sea. What a rogue wave really is. A rogue wave is not just a big wave in bad weather. That distinction matters. NOAA defines rogue waves as waves greater than twice the size of surrounding waves. In other words, they are not simply part of an already huge regular swell. They are standout anomalies, individual waves that tower over their neighbors. They often arrive unexpectedly, may come from directions other than the prevailing wave field, and can appear in conditions where mariners do not expect one wave to vastly exceed the rest. NOAA and NOAA Jetstream both note that these waves are often steep-sided and described as walls of water with unusually deep troughs. That definition is important because it explains why these waves were so difficult to study historically. If you are in a storm with very large seas, a rogue wave is not merely the largest wave in a bad set. It is a statistical outlier. A wave that significantly exceeds what conventional models predict should be happening in that moment. That is why older science was skeptical. Oceanographers were not denying that big seas existed. They were questioning whether the ocean could spontaneously produce isolated giants that far exceeded the surrounding pattern. But the ocean can. And once instruments began catching them, the argument shifted from, do these things exist, to, how often do they happen, and why? Why science resisted the idea. It is easy now to mock that skepticism, but it is worth understanding why it existed. For much of the 20th century, wave forecasting relied heavily on linear models and statistical expectations built around large populations of waves. Those approaches were useful and often accurate for ordinary sea states, but they naturally treated exceptionally large individual waves as incredibly improbable. If a sailor reported a wave that seemed almost impossible under those assumptions, the easier explanation was human error. Fear changes perception. Memory exaggerates. Storm conditions confuse scale. From the point of view of an office or laboratory, that skepticism seemed reasonable. From the point of view of mariners, it could seem absurd. The tension between the two worlds lasted for years. Ships reported strange impacts. Some vessels suffered damage that did not fit cleanly into ordinary storm wave expectations. ESA later stated that rogue waves are now accepted as a leading cause of large ship sinkings. But crucially, it also emphasized that they were once dismissed as nautical myth. That is the heart of the title. Science did not invent rogue waves. Sailors forced science to catch up to them. And once researchers began gathering hard evidence, they discovered the sailors had not been describing fantasy. They had been describing a real ocean phenomenon that conventional assumptions had underestimated. The Dropner wave, the moment everything changed. If rogue waves have a courtroom exhibit, it is the Dropner wave. On January 1st, 1995, a downward-looking laser on the Dropner platform in the North Sea recorded a wave approximately 25.6 meters high. The surrounding significant wave height was around 12 meters, meaning the event met the rogue wave standard decisively. The measurement was taken by instruments on a fixed platform, not by witnesses shouting in terror from a ship's bridge. ESA, no AA-linked educational sources, and scientific summaries all treat Dropner as one of the landmark confirmations that rogue waves are real. This mattered for two reasons. First, it was measurable. Scientists could no longer explain the phenomenon away as unreliable eyewitness reporting. Second, it fit the stories too well. It was abrupt. It was disproportionate. It emerged from a sea state that was already rough, but not rough enough to make such a wave seem ordinary. It looked exactly like the kind of event mariners had been describing for generations. From that moment onward, the debate changed. Rogue waves were no longer folklore waiting for proof. They were a proven physical phenomenon demanding explanation. And once satellites joined the search, the story grew even more unsettling. The satellites revealed it wasn't just one wave. One of the most shocking developments came in 2004, when ESA reported that radar images from its ERS satellites had detected numerous rogue waves around the globe during just a few weeks of observation. ESA said these observations helped establish the widespread existence of such waves and showed that they were not isolated oddities of one sea or one storm. That revelation changed the scale of the problem. Before, a skeptic might argue that rogue waves were real but incredibly rare. After satellite evidence, the message became harder to ignore. The oceans were producing these waves far more broadly than many had assumed. They were not just North Sea accidents or isolated freaks of one region. They were part of the ocean's real behavior. And that was deeply unsettling for maritime safety because ship design, risk assessment, and forecasting had long been built around assumptions that now looked incomplete. When scientists say a phenomenon is rare, engineers hear manageable. When the sea says rarer than expected, but still common enough to matter, everything changes. What creates a monster wave? This is where the story becomes more scientific and, in some ways, more interesting. There is no single universal cause of rogue waves. Noé explains that they can form when winds and currents cause waves traveling at different speeds and from different directions to merge into one exceptionally large wave. The result is a temporary concentration of energy into a single giant crest. But that is only the broad picture. Researchers have explored several mechanisms. One involves wave focusing, where groups of waves align in a way that stacks their energy unusually high. Another involves strong currents that shorten wavelengths and steepen waves, making certain regions particularly dangerous. Crossing seas, where waves from different directions interact, can create unstable geometries that promote extreme peaks. More recent research has also looked at non-linear effects, where energy is transferred in ways simple linear models miss. ESA and scientific reviews both emphasize that rogue wave origins are tied to complex interactions between winds, currents, and wave systems rather than one neat trigger. That complexity is one reason the scientific community struggled with them for so long. Rogue waves are not easy to reproduce, easy to predict, or easy to reduce to a single formula. They sit at the edge where ocean physics becomes more chaotic than comfortable. In practical terms, that means the sea can occasionally concentrate its violence into one place, one shape, and one devastating moment. Why they are so dangerous to ships. A normal storm is dangerous because it batters a ship repeatedly. A rogue wave is dangerous because it can strike with the force of surprise. Its height matters, but so does its shape. Rogue waves are often described as unusually steep, with deep troughs and abrupt faces. That means the encounter is not like riding over a large rolling swell. It can be more like meeting a sudden wall. NOAA explicitly says these waves are often steep-sided with unusually deep troughs, which helps explain why they can hit vessels in ways crews are not prepared for. A large merchant vessel is built to survive heavy seas. But design assumptions depend on expected loads and expected wave behavior. A rogue wave can exceed both. ESA stated that rogue waves are now accepted as a leading cause of large ship sinkings. That is not sensational language. It reflects the fact that a sufficiently large and steep isolated wave can produce stresses that normal seakeeping models underestimate. That helps explain why some ships historically suffered bridge damage, deck failures, smashed windows, or hull stresses that seemed out of proportion to the broader storm. It was not always that the storm as a whole was beyond design expectations. Sometimes one wave was, and one wave can be enough. They do not always come in the worst storms. This is another reason rogue waves are so frightening. They are not confined to the most cinematic conditions. They can occur in severe storms, yes, but they can also emerge in sea states where the surrounding waves do not seem apocalyptic enough to justify what suddenly appears. That is part of why so many early witness reports sounded exaggerated. If the whole sea is already full of enormous water mountains, one more huge wave sounds less impossible. But a rogue wave often shocks precisely because it is disproportionately larger than the waves around it. That is built into the definition itself. A wave more than twice the surrounding significant height is alarming not just as a raw number, but because it breaks the rhythm of the sea. Mariners learn to read wave fields. Rogue waves violate that reading. They are the ocean breaking its own pattern. The wall of water description wasn't poetry. When sailors described rogue waves as walls of water, many people treated that language as the exaggeration of frightened men. But NOAA now uses almost the same phrase in its official explanation, noting that most reports say rogue waves look like walls of water. That is significant. It shows that eyewitness language, once dismissed as melodrama, was often physically accurate. These waves can present as steep-sided and abrupt enough to justify exactly that description. This is one of the most satisfying reversals in the whole story. The people closest to danger were not merely being dramatic. They were trying to describe a real hydrodynamic event using the most direct language they had, and the science eventually caught up. The Ucluelet wave and the modern era of detection. If Dropner proved rogue waves existed, later detections proved the story was still getting stranger. In November 2020, a buoy off Ucluelet on the west coast of Vancouver Island recorded a lone 17.6-meter wave among surrounding waves of about 6 meters. In proportional terms, it was nearly 3 times the height of neighboring waves. While it was smaller in raw height than Dropner, it drew major attention because of just how extreme it was relative to the surrounding sea state. Marine Labs described it as record-breaking in that proportional sense, and the event became widely discussed as one of the most extreme rogue wave detections on record. This modern detection mattered because it showed that even with decades of improved science, rogue waves are still capable of startling researchers. We now know they are real. We define them more clearly. We observe them with better tools. And yet, when one appears in a particularly extreme form, it still shocks the people who study the ocean professionally. That tells you something important. Knowledge has reduced denial, but it has not eliminated surprise. The sea still has room to exceed expectation. why forecasting them is still so hard. You might think that once something is scientifically accepted, forecasting it becomes easy. Not here. NOAA is clear that rogue waves are very unpredictable. The ocean can be modeled in broad patterns, but the exact concentration of energy that produces a rogue wave is much harder to anticipate in a specific place and time. That is because the event often depends on rapidly changing local interactions among wave trains, winds, currents, and nonlinear amplification. Forecast systems can identify dangerous sea states and regions where the probability of extreme waves may be elevated. They can warn about strong currents, crossing swells, and bad storm geometry. But forecasting a single rogue wave precisely is far harder than forecasting the overall storm itself. That unpredictability is part of what made scientists hesitate historically, and part of what still makes rogue waves operationally frightening. We understand more about why they can happen. We still cannot treat them as something easy to pinpoint. In other words, rogue waves moved from myth to known hazard, but not to fully controlled phenomenon. What this changed in ocean science. The acceptance of rogue waves forced a change in scientific culture. It reminded researchers that the ocean is not always well described by averages. Mean conditions can hide lethal outliers. Statistical comfort can fail when nonlinear systems concentrate energy in extreme events. It also showed the value of integrating eyewitness accounts with instrumentation instead of assuming that anything outside the model must be human error. That lesson reaches beyond rogue waves. Science advances partly by skepticism, but it also advances by noticing when reality keeps refusing to fit the theory. Rogue waves became one of the clearest modern examples of that tension. The old models were not useless, they were incomplete, and the ocean exploited the gap. The deeper truth, the sea was telling the truth first. There is something almost poetic about the way this story unfolded. Long before satellites, long before laser measurements, long before formal definitions, the ocean had already announced the existence of rogue waves through the testimony of people who survived them. The mariners were the data before the instruments were. Science did what science often does. It hesitated, doubted, refined, measured, and eventually accepted. That is not failure. That is the process. But in this case, the delay matters because it reveals how easily a phenomenon can be called impossible simply because it does not fit the available model. The giant waves existed whether science admitted them or not. They rose in darkness, struck steel, terrified crews, and vanished back into the sea while arguments continued on land. The ocean never needed permission. The giant waves scientists once refused to admit exist are now part of accepted ocean science. NOAA defines them. ESA helped show they are widespread. The Dropner wave proved them in hard measurements. Later observations confirmed that the world's oceans can produce sudden, isolated walls of water far beyond the rhythm around them. And that may be the most unsettling part of all. The ocean was not hiding a fantasy. It was hiding a fact that looked too extreme to believe until the instruments finally caught up. Rogue waves are real, dangerous, unpredictable, and, in some parts of the sea, likely more important than earlier generations of scientists were willing to admit. So, the next time someone describes the ocean as beautiful, ancient, and mysterious, remember this: there are moments when the sea can gather its force into a single impossible shape, raise it higher than reason expects, and send it forward like a moving cliff. And whether science believed it or not, the wave was always real.